Okay, so now in this video, we're gonna start to practice differentiating functions that involve the natural log of x. And here we formally define the derivative of the natural log of x as being 1 over x. So if we have the chain rule, we simply would take the derivative of the inside function. Let's say if we make it the natural log of u, so using u substitution, we would take the derivative of the inside, so derivative of u with respect to x, times 1 over u. So 1 over u times du over dx. And that's essentially the same thing, but just using the chain rule. But as always, I like to have you guys practice because that's the best way to get good at this stuff. So let's go through some practice problems. Okay, so we're going to differentiate each of these. So the first one we have the natural log of 2x. So the inside we have 2x. So what we do is just take 1 over whatever that inside is. So we're going to have 1 over 2x. And this will be multiplied by the derivative of 2x. This is following the chain rule. So the derivative of 2x is just going to be 2. So we just multiply this by 2. And that's really it. And the 2's actually cancel out, and it just becomes 1 over x. All right, the next one we got that the inside here is x squared plus 1. So when we differentiate this, make it simple at first. Just do 1 over the inside quantity. So 1 over x squared plus 1. And then this, we're going to multiply it by the derivative of x squared plus 1. So remember, the inside is x squared plus 1. So using the chain rule, we multiply by the derivative of x squared plus 1, which is just going to be 2x. And this really can't be simplified, so we are just going to rewrite this as 2x over x squared plus 1. And that's it. All right, C, we are looking for the derivative of x times the natural log of x. So here we have two functions, and this is going to be the product rule. We got x as one of the functions and the natural log of x as the other. So remember what the product rule says, where you have the derivative of f times g. This will just be the derivative of f times g plus f times the derivative of g. So let's go ahead. We'll take the derivative of x first, which will just be 1. So we're just going to have 1 times the natural log of x plus, this time we keep the f, or x in this case, as is. And we're going to multiply this by the derivative of the natural log of x, which will just be 1 over x. And this just simplifies the natural log of x plus 1. All right, for D, we have the derivative of the natural log of x, all to the third power. Now, this is going to involve using the chain rule, and we're going to use the power rule because the outside function is the cube function. The outside function is that, function being raised to the third power. So we take the derivative of the outside first. So we're going to have 3 times the natural log of x, all to the second power. And then we multiply this by the derivative of the inside, or the derivative of the natural log of x, which would just be 1 over x. And this won't really simplify into anything. So we'll just keep this as 3 times the natural log of x, all to the second power over x. All right, problem 2, we got another example of chain rule. So we want to find the derivative of this function. So we have the inside function. Let's rewrite this as the natural log of 2x plus 1. And that 2x plus 1 is being raised to the 1/2 power. Same thing. Now, instead of using chain rule, which you could, it might actually be easier just to use one of the log properties, which allows you to move the exponent of this expression as a coefficient. So using the log property, this is actually equal to 1/2 times the natural log of 2x plus 1. Remember, with the log properties, you move the exponent into a coefficient there. So this is the same thing. Taking the derivative of this is much easier. So from here, we're going to differentiate. So we'll find f prime of x. Let's keep that 1/2 as a leading coefficient. So 1/2 times the derivative of the natural log of 2x plus 1. So the inside is a 2x plus 1. So let's first just do 1 over 2x plus 1. And then we're going to multiply this by the derivative of 2x plus 1, which is just going to be 2, because the derivative of 2x plus 1 is just 2. And here, these 2's actually cancel, and all you're actually left with is 1 over 2x plus 1. All right, number 3. Okay, so we got f of x is the natural log of x times x squared plus 1 all squared all over the square root of 2x cubed minus 1. Okay, so this is another good example of how we want to use logarithmic properties to make our lives a lot easier. So let me put this whole thing in parentheses first. So let's start off by breaking this up into differences. Because remember, we have the natural log of a over b is the same as the natural log of a minus the natural log of b. So what we have here, we can rewrite this as the natural log of x times x squared plus 1 squared minus the natural log of, let me put that in square root, of the square root of 2x cubed minus 1. Now, what we can do here is just maybe expand this to make an easier logarithm to work with. And this thing, let's rewrite it as a power. So what we're going to have this is the natural log of this whole thing, remember, is being squared, the natural log of x times x to the 4th plus x squared plus 1. So we're going to have the natural log of x times x to the 4th plus 2x squared plus 1 minus the natural log of 2x cubed minus 1 all to the 1/2 power. Keeping this going, let's just rewrite and distribute that x. Natural log of x to the 5th plus 2x cubed plus x minus the natural log of 2x cubed minus 1 to the 1/2 power. Oh yeah, actually, let's move this 1/2 here. Let's put this as a coefficient again, because that'll make it easier to work with instead of having to use the chain rule. So whoops, let's put that. Let's actually make that 1/2 our coefficient. It's kind of what we did in the previous problem. So minus 1/2 times the natural log of 2x cubed minus 1 using the logarithmic property. Now from here, we can differentiate, because all we have to do is then multiply 1 over this times the derivative of this for that first derivative. So let's go ahead. F prime of x will be 1 over this, 1 over the inside, 1 over x to the fifth, plus 2x cubed plus x, multiplied by the derivative of this entire expression. And that'll be multiplied by 5x to the fourth, plus 6x squared, plus 1, minus 1/2. Now, let's take the derivative of this. So 1 over the derivative of this. 1 over this. 1 over 2x cubed. Minus 1. And then this will be multiplied by the derivative of 2x cubed minus 1. So multiplied by simply 6x squared. And then from here, all that's really left is to simplify this, which is really not going to be that much, that much more neater. Let's just take one more step. So here we're going to have 5x to the fourth plus 6x squared plus 1 over x to the fifth plus 2x cubed plus x minus this 2 will, simplify. Now it would just be a 3 on top. So minus a 3x squared over the 2x cubed minus 1. And that's really going to be our final answer. All right, so there you go.